In this video, we're going to look at an example problem covering the topics of section 8.1. So something you might want to do if you were watching this would be to try to write the answer to the question and then, pause the video, try to write the answer to the question, and then see what I have written and see how that matches with what you have. So the example that we have here is a large company is concerned that many of its employees are in poor physical condition, which can result in decreased productivity. To determine how many steps each employee takes per day, on average, the company provides a pedometer to 50 randomly selected employees to use for one 24-hour period. After collecting the data, the company statistician reports a 95% confidence interval of 4,547 steps to 8,473 steps. So the first question is interpret the confidence level. In other words, what does 95% confident mean in the context of this problem? So this is one where you might go ahead and start writing what you think this means and then check on my answer, pause, and then come back and I will do my answer. Okay. The confidence level of 95% means if I were to take many, many random samples of 50 employees and make confidence intervals, I would expect about 95% of them to contain the true mean number of steps taken per day. Okay, so that would be the interpretation of 95% confidence. Now the next one says interpret the confidence interval. So that is the question. So what does 5,457 to 8,473 mean in the context of this situation? So I'll just write in this context. So what does that mean? Okay, so once again, if you want to pause and try it yourself first and then come back, then I will show you my answer. Okay, welcome back. If you didn't leave, then you're not welcome. Just kidding. I am 95% confident that the interval from 4,547 to 8,473 captures the true mean number of steps taken per day by employees in this company. Okay, that's the interpretation of the confidence interval. Next question. What is the point estimate that was used to create the interval, and what is the margin of error? So this is something we haven't really talked about yet, but how is an interval created? Well, remember that it is the point estimate plus or minus a margin of error. So if this is the left-hand side of the interval and this is the right-hand side, the point estimate is halfway between those two numbers. So if I just average the two numbers, I get the middle. So the middle of this interval would be 6,510. So that would be the sample mean that was used to create this interval. Then the margin of error would be whatever we add or subtract on both sides. So if we take 8,473 minus 6,510, we get that we added 1,963 to get to the 8,473, which would mean we would subtract it to get to the 4,547. So this is the point estimate and this is the margin of error. Next question. Recent guidelines suggest that people aim for 10,000 steps per day. Is there convincing evidence that the employees of this company are not meeting the guideline on average? So, take a look at our interval. I'm 95% confident that the interval from 4,547 to 8,473 captures the true mean number of steps taken per day by employees in this company. So because of that statement, saying that the true mean is 10,000 is not really likely to happen because it's very far outside of that interval. 10,000 is not, oops, I wanted to not show the next one yet. Okay, 10,000 is not in the confidence, oh, that's supposed to say confidence interval, is not in the confidence interval. So it is highly unlikely that the true mean is 10,000 steps. Next question. How would the interval change if I used 90% confidence instead of 95%? Basically, would the interval get narrower or would it get wider? Take a minute to think. it would get narrower. Okay, I'm less confident that it contains the true population proportion because it is narrower. It's more precise, therefore I miss more often. If I want to have a higher level of confidence, I have to have a wider interval or a smaller sample size. So how would the interval change if the sample size was 30 instead of 50? Reducing the sample size actually makes things worse. It would make the interval wider, because remember, increasing sample size allows us to have a more precise estimate even with the same level of confidence. Increasing sample size reduces variability in our intervals. So decreasing the sample size would increase variability. So there's a practice problem for section 8.1. Hopefully those concepts are starting to sink in.